In the early months of the Pacific War, where Imperial Japan was finally checked in its insatiable advance, and the United States and her allies gathered their strength to push her back, two aircraft stood out. Meeting over oceans and malaria-infested islands, the Grumman F-4F Wildcat and Mitsubishi Reisen met in deadly combat and pitted two very different cultures against each other. The two aircraft have very different capabilities as well as their own unique flaws. The men flying these two fighters had to strive to overcome their own challenges or face defeat in the skies of the Pacific. In this video, I'd like to invite you to imagine that somehow you're transported back to 1942, and just before you travel, you're given the choice to fly and fight in either the Wildcat or the Zero. While you might be thinking that one of these aircraft is clearly superior to the other, I want to try and show you that there's more to it than legend and reputation. Before making your choice, I'm going to take you through the development of each of these aircraft, as well as the capabilities and the drawbacks that each had. We're going to talk about the tactics that were used to get the best out of each aircraft, as well as the men sitting in the cockpit and their level of training. I literally put days of work into this video, and to be fair, it's quite a long one. So why not grab yourself a cuppa, or perhaps something stronger, and enjoy. And don't forget, let me know in the comments which aircraft you would choose. I'm always fascinated when I have a chance to delve into the history of an aircraft's development, and the Wildcat and Zero Sen don't fail to deliver on this regard. While one was a slow starter and was initially beaten out by what many people call the worst World War II fighter, the other had such challenging requirements, all but one company bowed out of the race to design it. So how did the US Navy and Marine Corps, not to mention the British Fleet Air Arm, find themselves fighting a world war armed with a Grumman Wildcat? And how did the Japanese, thought to be technologically in advance, produce an aircraft celebrated as a wonder machine? The story of the Grumman Wildcat, which encompasses its early operational variants, the F4F3, right up to its powerful cousin, the FM2, all starts with two aircraft, the ones it was designed to replace. As the 1930s dawned, the United States Navy saw a need to replace its slow biplane bombers and fighters with sleeker and more modern monoplane all-metal designs. In 1934, prototype contracts had been awarded for the Douglas XTBD-1 as a promising new torpedo bomber, and for new monoplane dive bombers with contracts for the Brewster XSBA-1, Northrop XBT-1 and Vaunt, or VAT, XSB-2U-1. The next year, the Navy aimed to find a replacement for its two frontline fighters, the Curtiss BF-2C-1 and Grumman F-2F-1, then only about 20 miles an hour faster than the United States Army Air Corps' frontline bombers. Grumman was already in the process of designing and building an improvement on its current F-2F-1 design in the form of the F-3F, but it was already underperforming. In August 1935, the Seversky SEV-1, precursor of the Seversky P-35, achieved a top speed of 284 miles per hour in tests for the United States Army Air Corps at Wright Field. This was a strong indication to the Navy that monoplanes were the way of the future. Yet, when given another prototype contract in March 1936 for its XF4F1 design, Grumman was in fact proposing an improved version of its F3F design, basically another biplane. The prototype would be powered by an 800 horsepower Pratt & Whitney or Wright engine, giving an estimated top speed of 264 miles per hour. However, this project would ultimately be abandoned for two reasons. Firstly, Grumman engineers worked out that by fitting existing F3Fs with a 950 horsepower Wright XR1820 Cyclone engine, they could increase its top speed to over 255 miles per hour, just shy of the XF4F1's own expected speed. Secondly, a contract to develop the Brewster XF2A1 was issued in June 1936, a monoplane design. Grumman saw little value in pursuing yet another biplane carrier fighter, and so did the Navy, and thus the company went back to the drawing board and was soon offered a contract for its XF4F2 prototype on July 28, 1936. Taking a page from Sidney Cam's book, the XF4F2 was essentially a monoplane version of its biplane XF4F1 ancestor. Looking at the two aircraft, you'd see that the XF-4F2 kept the retractable landing gear and cockpit location of the XF-4F1, but had its monoplane wing placed at the mid-fuselage area. At the request of the Navy, the newly developed Pratt & Whitney XR1830-66 engine was fitted in one of Grumman's prototype fighters. This 14-cylinder two-row engine with its single-stage supercharger offered 1,050 horsepower on takeoff and 900 horsepower at 9,000 feet, with the possibility of even more power with further development. Grumman engineers estimated that this engine would give the XF-4F2 a top speed of 290 miles per hour, way in excess of the abandoned F4F1 project. Making its first flight on September 2, 1937 at Grumman's plant at Bethpage, Long Island, the XF-4F2 was sent for naval testing at the Naval Air Station Anacostia near Washington, D.C. At the same time, the Navy conducted trials with the Brewster XF-2A1 and the Seversky NF-1, which was a naval version of the P-35. The testing program was very thorough and lasted until April 1938. However, problems with the Pratt & Whitney engine hampered testing of the XF-4F2. The prototype suffered a serious accident when the engine cut out shortly after takeoff in Philadelphia, where the airplane had been conducting catapult tests and simulated carrier landings. No doubt because of these teething problems, a contract for 54 production versions was awarded to Brewster for its XF-2A1 in June 1938, despite the XF-4F2 being faster. If you want to hear a bit more about how that worked out for the future Buffalo, please watch my video about this misunderstood fighter after you finish this one. But the feedback from the Navy wasn't all bad. Seeing the potential, they continued with the development of the XF-4F2 alongside Grumman, and finally issued a contract for a revised XF-4F3 in October 1938. The new design would be fitted with the heavier but more powerful Pratt & Whitney XR1830-76 engine, also boasting a two-stage, two-speed supercharger, providing 1,200 horsepower for takeoff, 1,050 horsepower at 11,000 feet, and 1,000 horsepower at 19,000 feet. Grumman also made other changes to the new prototype, including adding 4 feet to the original 34 feet wingspan and replacing the rounded wingtip for squared off ones. This was all in a bid to bring the wing loading back within an acceptable limit given the heavier engine. Making its maiden flight on February 12, 1939, the XF-4F3 then underwent flight tests by the Navy, which lasted until July. It was found that with the newer engine and supercharger, the XF-4F3 achieved a maximum speed of 333.5 miles per hour, an improvement of over 40 miles per hour on the XF-4F2. The US Navy's Bureau of Inspection and Survey subsequently recommended that the Grumman fighter be accepted as a service type, despite a conclusion that the fighter was longitudinally and laterally inadequate in landing. And so, after nearly 24 months of effort, Grumman was awarded a contract for 54 F4F3 fighters in August 1939. However, before the first production models came off the assembly line, further modifications were made. After undergoing wind tunnel trials at Langley, Virginia, something the Brewster Buffalo also underwent, several refinements were suggested. The area of the vertical tail was increased and moved slightly back, increasing the length of the XF-4F3 by 19 inches, while the tail planes were raised 20 inches to the base of the tail fin. In addition, an extended turtle deck was also added between the tail fin and the cockpit, giving a smoother contour. The F4F3s were armed with twin .50 caliber machine guns in each wing, instead of the nose-mounted .30 calibers and single-wing mounted .50 calibers first suggested. They also did not boast self-sealing fuel tanks, which was actually quite common for the period. Interestingly, the first F3F3s would not be welcomed into their first operational squadrons by Americans, but by British and Commonwealth pilots. With the fall of France in June 1940, the Fleet Air Arm took over airframes earmarked for the French. The 100 Wright Cyclone-powered aircraft were pressed into service as Martlet Mark 1s by the British, and the birds that never rested were soon in action. On Christmas Day 1940, a Ju-88 fell to the guns of a British Martlet, opening the score sheet for the Grumman F4F. The US Navy received its first F4F3s in August, and by December, deliveries to frontline squadrons began with VF-4, assigned to the air group embarked in USS Ranger, and VF-7 aboard USS Wasp. Development for the F4F3 continued as the R1830-76's two-stage superchargers remained a cause for concern. The Navy, in the form of the X-F4F6, fitted a single-stage, two-speed supercharged Pratt & Whitney R1830-90 engine at the end of 1940. This re-engined fighter had similar handling qualities to the F4F3, but could only muster a top speed of 319 miles per hour. Designated the F4F3A, 95 aircraft were ordered to prevent against any shortage in building two-stage supercharger engines. Although 30 airframes from this order would find themselves in British service as Martlet Mark IIIs, the rest would be delivered to American squadrons. By October 1941, perhaps unhappy with the heraldic British name given to their fighter, the US Navy dubbed the F4F as the Wildcat. By the time the Japanese attacked Pearl Harbor, Grumman had delivered 183 F4F3s and 65 F4F3As, which equipped 8 US Navy and 3 US Marine Corps squadrons. But again, this was not the last time engineers would try to improve upon the F4F Wildcat. Initially, the Navy had said that folding wings were neither necessary nor desired in its 1930 bid for prototypes. By the end of the Battle of the Coral Sea, they had seen that this was a mistake. Future battles would require more aircraft below deck. To help provide its carriers with more air power, engineers approached the question of how to reduce the wingspan of the Wildcat on deck. A similar issue we'll see with the Mitsubishi Zero later. Legend has it that Grumman engineers worked out the concept using a rubber eraser and paper clips. However it was imagined, the result was a Wildcat with wings that could be folded neatly along its fuselage. With a width of 38 feet in flight, the fighter could take up around 14 feet in the hangar. Another change in what would become the F4F4 was its armament, but we'll talk about this more in another part of the video. The first of the F4F4s were assigned to the Atlantic Fleet in February 1942, serving with VF-71 on board Wasp, followed by VF-8 on board HSS Hornet. By the end of May 1942, most of the US Navy's fighter squadrons and 2 Marine Corps squadrons had converted to the F4F4. During the course of that year, Grumman would deliver 1,164 F4F4s to the US Navy and the US Marine Corps. This was to be the main variant which would meet the Japanese onslaught during 1942. Although the F4F Wildcat would be largely replaced by F4U Corsairs in 1943 and its fellow feline fighter, the F6F Hellcat, the aircraft wasn't completely done. A new variant of the fighter, the FM2, was designed to be used for close air support while serving on smaller carriers. Fitted with a more powerful engine, the 1350 horsepower Wright R1820-56, and with tweaks to its tower arrangement and armament, the new fighter bomber fought in the invasion of the Philippines and Okinawa. We can basically look at the FM2 as an improved F4F4, but one that was built by General Motors instead of Grumman. Despite only boasting 4.50 caliber guns, the 5,000 or so FM2 Wildcats built established a kill ratio of 32-1, admittedly against older types of Japanese aircraft and less well-trained pilots. This figure was remarkable nonetheless. The Mitsubishi A6M2 Raisin, or Zero as I'll refer to it here, is one of those aircraft that most people have heard of, even if they aren't committed aviation enthusiasts like us. What has led to the Zero's reputation as one of the best fighters of the Second World War, at least at the start, was that nobody in the West expected it. Before we go into the development of this impressive aircraft, let's just take a moment to explore why the Zero was such a shock to Allied pilots first meeting it in 1941. Japan, which had been an unindustrialized feudal state well into the 19th century, was not seen as a powerhouse of aircraft design even in the 1930s. Much as China today might be seen as an impressive industrial mimic, so too was Japan at the time. I mention this because I think it had a great impact on Allied strategy in the Pacific Theatre in 1940 and 1941. Just to illustrate the opinion, let's look at an article from the March 1941 edition of British aviation magazine The Aeroplane, which said, "The Japanese are, by nature, imitators and lack originality. Japanese aviation has, therefore, a long way to go before it will be able to compete successfully with, or even combat, the decadent European and American democracies." An American aviation writer shared this opinion, stating that the Japanese
have not yet gotten much beyond merely imitating what others have done. At that, they are the world's finest, but imitativeness is little help in aeronautics.
However, not everyone was blind to the facts, as the Japanese and their military prowess was clear for anyone to see in their war against China. In March 1939, the US Navy's Office of Intelligence had warned against this very complacency.
No possible benefits can be derived from underestimating their war-making powers on the land, on the sea, or in the air.
The Mitsubishi A6M2 Navy Type 0 carrier fighter was intended to be a technological leap to replace a former technological leap. The Mitsubishi A5M Naval Type 96 carrier fighter, which first flew on the 4th of February 1935, became the first monoplane fighter to serve with any navy. It entered combat 2 years later against the Chinese and quickly dominated the Curtiss Hawk 3s and P-26 pea shooters they encountered. However, pilots reported that their twin 7.7mm nose-mounted machine guns didn't have the destructive force to drop Chinese bombers from the sky. As good as the A5M was as an aircraft, it also did not reflect the Imperial Japanese Naval Air Force's developing strategy for its fighter aircraft. Rather than relying only on its fighter force as a means of carrier protection, in the future their role would also focus on long-range escort missions. So in 1937 the Koku Honbu, or Aviation Bureau, met with the Mitsubishi and Nakajima aircraft companies to discuss plans for a new fighter. This conference was attended by Jiro Horikoshi, the man behind the A5M design. By October, the requirements for the new 12 carrier fighter prototype had been finalised and sent to the two companies. They called for a maximum speed in excess of 310 miles per hour, ability to climb to 9,800 feet in 3 minutes and 30 seconds, a range of 110 miles with a normal fuel load, and 1,685 miles with auxiliary fuel tanks. Manoeuvrability equal to or better than the A5M Type 96 fighter, a wingspan of no more than 39 feet and 4 inches, armament of two 20mm cannons in the wing and two 7.7mm machine guns in the nose, ability to take off in less than 230 feet into a 30 mile per hour wind, a landing speed of less than 67 miles per hour. In essence, the IJNAF was asking for a bomber interceptor with heavy enough armament to successfully defend a carrier fleet, while also having the range to reach enemy targets hundreds of miles away, where the aircraft was expected to dominate its fighter counterparts. Jiro Horikoshi quickly identified that the IJNAF's request called for two roles which were fairly incompatible with each other. A long-range escort fighter traditionally called for a heavier aircraft, capable of carrying large amounts of fuel, as well as the requested heavy armament. An interceptor with a rapid rate of climb needed to be light. Reconciling the two roles would be challenging, so much so that the Nakajima Aircraft Company soon bowed out of the competition. Horikoshi started his design process by first considering which engine to use. The power plant would determine a number of things, including the shape of the fuselage and the drag it produced, as well as the overall weight of the final aircraft. The issue was that the Japanese aircraft industry was woefully underdeveloped, and when he looked, the cupboard was relatively bare. Horikoshi's best options, it seemed, were to choose between the Mitsubishi Zusei, or Holy Star, and the Mitsubishi Kensei, or Golden Star, both 14-cylinder 2-row radial engines. Although he favoured the Kinsei 46 engine, which had a superior rating of 1070 horsepower to the Zusei 13's rating of 870 horsepower, it was heavier and had a larger diameter and higher fuel consumption. To avoid a larger airframe to house the bigger engine and fuel required to feed it, the team selected the Zusei 13 instead. This was largely because Horikoshi and his team calculated that they could build a fighter weighing around 5,000 pounds, which would have been about 1,600 pounds lighter than an aircraft equipped with the Kinsei 46. With a suitable engine selected for the prototype, the priority now became finding a balance between an airframe, strong enough to withstand carrier operations, but light enough to increase its power and range. With the need to maximise its armament and fuel capacity, the task became a real challenge for the Mitsubishi team. Nevertheless, they managed to achieve this aim in a few distinct ways. Firstly, Horikoshi decided not to adhere to one of the Imperial Japanese Navy's stipulations. It said that all aircraft must have a safety factor of 1.8 times the maximum load in terms of structural strength. The Zero would be built with a safety factor slightly below this to save on the added weight. Horikoshi also managed to lighten the airframe by adapting the production methods. By making the wing a single unit from root to tip and also making it an integral part of the fuselage center section, he eliminated the need for heavy wing mounting fittings. This also made for a very strong wing assembly. Another way in which the Mitsubishi team was able to save on weight was by using a new strong zinc aluminium alloy known as Extra Super Duralumin, which had just been developed by the Sumitomo Metal Company. By using thin sheets of ESD, Horikoshi could skin the entire airframe without adding considerably to the overall weight. In addition to making the aircraft light, the team also had to consider maneuverability and its ability to destroy the enemy. Horikoshi gave the prototype a large wing in which he could house the hard-hitting 20mm cannons, as well as additional fuel reserves. The wing was also given long ailerons for better maneuverability, as well as a slight downward twist which helped delay wingtip stalls. All of this gave it excellent lateral control. To make the prototype a better gun platform, the fuselage was lengthened and the area of the vertical and horizontal tailplane were increased. The team also paid close attention to making the airframe as aerodynamic as possible, including flush riveting and a streamlined drop tank into the design. While meeting the goal for saving weight, all these techniques would not make for easy production, and this would come back to haunt the Japanese later on. Two improvements on the A5M were the inclusion of a wide retractable undercarriage, which was excellent for carrier operations, and a high and entirely enclosed cockpit, which gave the pilot excellent visibility for normal operation and combat. Much better than the Wildcat's own canopy, we could argue. The prototype 12She carrier fighter flew for the first time on the 1st of April 1939, but development wasn't quite finished yet. The IJNAF made it clear that it intended to change the engine from the 870 horsepower Mitsubishi Zusei 13 to the 950 horsepower Nakajima Sakai 12, itself also a 14-cylinder radial engine. Although slightly bigger than the original power plant, it was soon accommodated into the airframe, and further tests revealed the prototype met and even surpassed the original Navy requirements. The new engine, which would power many versions of the aircraft until 1945, gave it a top speed of 331 miles per hour, some 20 miles per hour above the brief. The Mitsubishi A6M2 was formally accepted to the IJNAF on July 31, 1940 as the Type 0 carrier fighter Model 11, or Reizen to its crews and Zeke or Zero to its enemies. Interestingly, the Type 0 designation was based on the year of introduction into service, not 1940 but 2600 in the Imperial Japanese calendar. Now, strange as that is, I'm kind of used to that here in Taiwan because it's officially the year 111, or 111 years since the Republic was formed. So that's just a strange fact for your next pub quiz. Before the Zero had been officially accepted by the Imperial Japanese Navy, a small batch of 15 had been sent to the Chinese front for evaluation. Initially, the A5M pilots were dubious about the new fighter's capabilities. In initial testing against their own Type 96s, the Zero was not able to shake the older fighter in straight dogfights. However, in combat against the enemy, the Zero soon showed itself to be far superior than the A5M. On September the 13th, 1940, a formation of Zeros, and we can assume no more than 15 were involved, met an estimated 30 Polikarpov I-15Bs and I-16 fighters. 27 of the Chinese-operated aircraft were claimed by the Japanese in a 10-minute battle. By the end of 1940, Zeros had claimed 59 fighters shot down and an additional 101 destroyed on the ground, all for the loss of just 3 aircraft, all of which fell to anti-aircraft fire. The legend of the Zero was being formed. As the A6M2 was being pushed into production, it was found that the 39-foot 4.7-inch wingspan, although narrow enough to fit in current carrier elevators, didn't leave much room for error. And so a retractable wingtip assembly was installed on the 65th fighter on the assembly line to reduce the span by some 20 inches on each wing. The new configuration was designated as the Model 21, and this became the mainstay of the Imperial Japanese Navy fleet for much of 1941 and into 1942. However, the Zero was by no means the perfect aircraft its reputation makes it out to be. Combat in China had revealed that the extremely manoeuvrable fighter at low speed did not perform well in high-speed dives. Aileron flutter was a real issue, and even above speeds of as little as 180 miles per hour, aileron control was sluggish. As the speed increased, so did the danger to the pilot. A solution was eventually found which involved making some changes to the wing surface thickness and strength, as well as installing external balances. This was not achieved before 2 pilots lost their lives, but did happen before the attack on Pearl Harbor. Another criticism that came out of this Sino-Japanese incident was the underwhelming effect of the Zero's 20mm cannons, which I'll talk about later in the video. Another complaint was the A6M2's lack of high altitude performance and shortcomings in a dive. Mitsubishi tried to address these concerns and more in an improved version of the Zero, which went into development in mid-1941. The new airframe was equipped with a more powerful Sakai 21 engine with 1,130 horsepower. It was also suggested by its test pilots that Mitsubishi do away with the rather pathetic folding wing feature of the Model 21 and just shorten the wingspan by 3 feet, as well as installing blunt wingtips. This had the effect of reducing the length of the ailerons by about a foot. Although this did improve the rate of roll at higher speeds, it led to a small loss in overall manoeuvrability. The new and improved Zero, which entered service in early 1942 as the A6M3 Type Zero carrier fighter, Model 32, only gained about 6 to 8 miles per hour with the new engine, but was certainly an improvement on the flaws the original Zero possessed. Of course, the Zero's development didn't stop with the Model 32, but for our direct comparison of the Wildcat and Zero as adversaries, let's leave this part of the story there. So after that rather in-depth and no doubt rather long-winded explanation of the development of these two aircraft, let's compare the most important variants side by side in terms of the numbers that count. In terms of speed, the Zero was slightly faster as it developed from the Model 21 to the Model 32 in comparison to the Wildcat. That being said, the F4F3 reportedly had a similar speeds to the Model 11 and 21 at certain altitudes. In fact, the Zero was used to best effect at low speeds, where it was much more manoeuvrable than the Wildcat. The Wildcat excelled when altitude was converted into diving speed, a manoeuvre Model 11 and 21 Zeros couldn't match or escape. The diving characteristics of the Zero were improved with the introduction of the Model 32, but not entirely fixed. What was clear is that the earlier Model Zeros experienced a greater drop-off in their speed performance the higher they flew, while F4F3s and F4F4s, notwithstanding the single-stage superpowered F4F3As, maintained a speed edge. As for altitude, the Wildcat could climb slightly higher than the Zero, but the difference in operational ceiling is almost negligible. As a rapid bomber interceptor, the Wildcat was less desirable than the Zero. When comparing the heaviest variants of each aircraft, the F4F4 and the Model 32, the former managed a climb rate of 2,190 feet per minute and the latter around 3,000 feet per minute. That being said, the stripped-down FM2 variant of the Wildcat, fitted with a 1,350 horsepower Wright R18-2056, did manage a reported climb rate of 3,650 feet per minute. As we're dealing with two fighters in our comparison to date, armament is a very important factor. What we essentially have when we look at the Mitsubishi Zero and the F4F Wildcat is the embodiment of the internal debate between rifle caliber machine guns, heavy machine guns, and cannon armament. If you're interested in this, be sure to check out my video that asks why the RAF armed themselves with .303s in World War II. While this debate might be won purely on the punch one of these fighters packed, there are also another two very important factors which I'm going to discuss later on. They are things which might actually make you think twice about which fighter you ultimately vote for. That being said, let's talk about what a Wildcat or Zero pilot actually had in his arsenal by 1942. As we've seen, the A6M2 and the later variant A6M3 were direct descendants of the hugely popular A5M Type 96. That little fighter would even see action itself during World War II, and many ended their days as sacrificial divine wind. The major problem faced by the A5M pilots was their twin nose-mounted synchronized machine guns lacked the hitting power to down heavy bombers. With the design and introduction of the A6M2, this problem was solved by installing a single 20mm cannon in each wing. The IJNAF had purchased a license to build the Oerlikon FF aircraft cannon in Japan. This became the Type 99-1 cannon, which was lightweight for its type and had a low muzzle velocity. Zeros were equipped with short-barreled Type 91 cannons and initially had a drum magazine containing 60 rounds. This was in comparison with the twin 7.7mm machine guns, which each had a magazine belt containing 500 rounds of ammunition. The Type 99-1 cannon provided a 520 to 540 rounds per minute rate of fire, depending on your source, and so an A6M2 pilot had just under 10 seconds of the harder hitting ammunition before being left with the less effective 7.7mm guns. Although it was indeed possible to down a Wildcat with the latter, it took a lot more ammunition to do it, while also trying to hit a twisting Wildcat with a low velocity 20mm gun was a challenge only the very best Japanese pilots could meet. Incidentally, a really unusual feature of the Zero was the pilot fired the guns not from the control column, but with a button on the throttle. He could also switch between his armament with a selector switch on the throttle. It was soon identified that more 20mm ammunition was needed, and when the A6M3s arrived with their bigger Sakai 21 engines, they were also fitted with 100 round, belt-fed Type 99-1 cannons. This increased the pilot's ammunition from about 3 2-second bursts to around 6. Why didn't the Japanese just up their firepower to a twin or a single .50 caliber machine gun in the nose? Ultimately, it was a question of weight. From previous videos, we've seen that a single .50 Browning was worth the weight of about 3 .303 Brownings. It must have been a similar situation for the Japanese versions of these machine guns. The Zero, even with its increased 1,130 horsepower and the AN6M3 Model 32 therein, couldn't justify an increase in its nose-mounted armament and stay competitive in other ways. The F4F Wildcat's armament was never in doubt. By the mid-1930s, the US had essentially settled on the .50 caliber machine guns for all its future fighters. The embryonic form of the F4F, the F3F1, was destined to carry a single .30 caliber and a .50 caliber nose-mounted machine gun. Technically, I believe I should call this latter machine gun a 12.7mm AN-M2, but that's a bit of a mouthful, so just know that's what I mean when I say a .50 caliber or a 50 cal in this video. This arrangement was later increased to an additional .50 caliber in the wing. However, by the time the first production F4F3s made it off the production line, they were fitted with twin wing-mounted .50 calibers, giving the later to be named Wildcat 4 guns in total. Possibly reports trickling back from the British who operated the Martlet Mark 1s may have given the impression that this 4 machine gun arrangement was barely adequate. However, in the Pacific Theatre, Navy and Marine pilots would find that the F4F3 and even the F4F3As had a lethal bite. In this configuration, each gun carried 450 rounds, which with the 12.7mm AN-M2's approximate 600 to 800 rounds per minute rate of fire, resulted in a good 30 seconds or so of continual fire from all 4 guns. In addition, a 2-second burst from a Wildcat could land 80 to 100 rounds on a target, give or take a shell, whereas a single burst from a Japanese 20mm might only land 35 or so rounds. Of course, there was also an additional 47 7.7mm rounds hurtling your way if the pilot had selected to fire all guns. With the modifications to the F4F4, which sported its folding wings for easier storage on a carrier, the design team also upped its arsenal. Outboard of the 2 original guns on each wing, a third was added. This meant the Wildcat's hitting power went up from a combined potential of 24 to 3200 rounds per minute to a whopping 36 to 4800. However, to accommodate the added weight of the guns, the ammunition for each was reduced from 450 rounds to just 240. This meant that although each burst was deadlier, a pilot was left with just 18 or so seconds of ammo to play with. Some pilots begrudged this change in armament and perhaps rightly argued that fewer guns with more ammo was the smarter choice. I also uncovered a claim that some Wildcat pilots chose to only fire a certain amount of guns to conserve ammunition. However, I wasn't able to find a reference to a gun selector option in the F4F, similar to what was available in the Zero. If you know anything about this, please let me know in the comments, and while you're there, please give the video a like to help it spread to others. As much as some pilots resented the F4F4 upgrade, I'm going to explain later in the video why they probably didn't need to worry too much once they got back in combat. Another excellent point that some of my viewers have brought up in previous comments is how the muzzle velocity of certain armament affected its potential range. One point to consider with the Zero is that its cannon and 7.7mm rounds wouldn't behave in quite the same way and would have different trajectories. This would no doubt affect its destructiveness in combat, so hopefully some of my more informed viewers can explain this further in the comments for me, which of course I'd really appreciate. Let's also not forget that both the Wildcat and the Zero could be fitted with bombs, the latter being used as a dive bomber later in the conflict. Although the F4F3 and the F4F4 could carry two 100-pound bombs, this required the removal of at least two machine guns to do so. The two aircraft could also carry drop tanks to extend their range. But I'm not going to say much more on this as I wanted to concentrate on their fighter rather than the fighter-bomber capabilities. Ordinarily in these videos I concentrate entirely on the aircraft and rarely cover the men who flew them. Although we're having a bit of fun and imagining ourselves sitting in one of these cockpits, if you were doing that in real life, the training you had received would have made a huge difference to your overall survival. Before looking at this idea in detail, I actually got my wires crossed. I thought, and rightly so, that the Japanese aircrew in 1941 were highly trained individuals and experts in the handling of their aircraft. However, I was under the illusion that most of their Allied counterparts were not. At any rate, the American naval aviator, or the Marine Corps pilot, was a force to be reckoned with. As the war progressed, the level of training and experience of the aircrew certainly suffered, disastrously so for the Japanese. But in 1941, they were almost on equal footing with some key differences. In fact, by the end of the 1930s, the US Navy, Marine Corps and the IJNAF resembled each other in the sense that they were not huge organisations. There were limited numbers of trained pilots on either side, but each man had hundreds of hours of experience and was by no means a greenhorn. What differentiated the two nations was that the US Navy and Marine Corps kept their pilot pools small, possibly for financial reasons, while the Japanese did it for elitist reasons. While the former retained a core of trained career personnel, supported by reserve in peacetime, the Japanese favoured quality over quantity, regardless of hostilities. It was really fascinating to research the pre-war and wartime training that American and Japanese pilots underwent before entering the Pacific theatre. I'm not going to go into too much detail, but I'd recommend you do your own research because it really broadened my own understanding of what happened post-1942. Let's just say that the average Japanese pilot going into combat in 1941 or 1942 had in excess of 250 hours of training, probably as many as 400. Many Zero pilots had seen combat in China, or at the very least had been trained in operational squadrons by those who had. In short, these were skilled aviators who knew their aircraft well and were the creme de la creme of what Japan had to offer. This was not the case just 2 years later, but that's a subject for another video. The average US naval pilot and his Marine cousin in 1941 could have anywhere from 300 to 400 flight hours. After President Roosevelt signed the Two-Ocean Navy Act in July 1940, which was to see an increase in naval power to 15,000 aircraft, training was streamlined. Even though few men left their training squadrons with less than 275 flight hours by the end of 1941. If you compare this to the traditional narrative of the Battle of Britain, where replacement pilots at times had fewer than 10 hours on the aircraft they would fight in, and not many flight hours overall, you can see the Americans and Japanese were in a much better position by 1942. The biggest difference, at least according to my research, was the emphasis placed by the Navy on gunnery. Pilots were taught how to judge distances and various levels of deflection so that they could instinctively fire on the enemy. In a time where gyroscopic gun sights were a thing of the future, the significance of this can't be understated. Possibly due to reports of sloppy shooting coming from the British recruits during the Battle of Britain, or just down to classic American ingenuity, this skill was forced home. The result was that American pilots who found themselves in combat with a highly maneuverable enemy could score devastating hits even if their sights were trained for the merest seconds. A combination of faster firing guns and excellent training made the Wildcat a deadly adversary that the Zero literally had no protection against. I'm going to cover just how deadly this was for the Japanese a little later in the video. However, let's not forget that the slower Wildcats were equally vulnerable to the Japanese themselves. One of the most important knock-on effects of excellent and extended training is the level of teamwork it created among both American and Japanese pilots respectively. Nevertheless, this is a double-edged sword, something we'll cover after these thoughts and tactics. As we've seen, both forces were extremely well trained and worked not as individuals but as teams. For the Americans in particular, the biggest issue when fighting a Zero in a Wildcat was how to overcome the F4F's own flaws. As 1942 progressed and tactics evolved, Zero pilots increasingly needed to find an effective reaction to American tactics which negated their own aircraft's deadliest attributes. News of the Zero and its reputation in China brought a chill to the Allies. Reports that made it into American hands said the Zero had a superior rate of climb, high speed, and could outturn any fighter. When this report crossed the desk of the commander of VF-3, Lieutenant John Thatch, he felt less than eager to convert to the then new F4F3s. He said,
"When I realized that this airplane, if this intelligence report were correct, had a speed in all three categories, it was pretty discouraging."
While some pilots put it all down to hype and propaganda on the part of the enemy, Thatch knew that even if the report was partially correct, they had a challenge on their hands. So he spent day and night trying to develop a response to such an enemy. Spending many a late night playing around with matches to represent aircraft, he worked on the theory that
we had good guns and could shoot and hit, even if we only had a fleeting second or two to take aim. Therefore, we had to do something to entice the opponent into giving us that one all-important opportunity. It was the only chance we had.
What he was to create was a system of mutual support between two elements of two aircraft. It was an approach that ultimately saved hundreds of American lives and what we know as the Thatch Weave. Unfortunately, Lieutenant Thatch was not a marketing guru, and he called it by the rather less catchy moniker, the beam defense position. Just rolls off the tongue, that one. In essence, the maneuver involved a two-man element flying parallel with another element. The men on the left kept a lookout to their right, and their squadron mates on the right kept their eyes to port. When a Zero latched onto one of the elements, the supporting aircraft would turn into them while the ones being attacked turned into their own squadron mates. This presented the supporting aircraft with a fleeting shooting opportunity, often a head-on pass with the Zero. The beauty of the system was that no verbal communication was needed, as you were already checking your squadron mate's tail. Simply by turning into them, the other two men, always watching you, knew to initiate the maneuver. However, Thatch was not able to test the theory until his involvement in the Battle of Midway. Meanwhile, other pilots were developing other responses to the Zero threat. Chief among them was Lieutenant Commander James Jimmy Flatley from VF-42, who met the Japanese during the Battle of the Coral Sea. Despite finding both the AM620 and A5M Type 96 tricky customers, during the battle, Flatley and his pilots developed tactics to survive and win against the carrier fighters. He said,
"The F4F3 airplane, properly handled, can beat the enemy carrier-based fighters encountered so far. This includes Type 0.
As it was very clear that the Zero Sen was far more maneuverable than the Wildcat, Flatley, when giving advice to his pilots, and in the vernacular of the day, said,
The most effective attack against a more maneuverable fighter is to obtain altitude advantage. Dive in, attack, and pull up, using speed gained in a dive to maintain altitude advantage. The old dogfight of chasing tails is not satisfactory and must not be employed when opposing Jap VF planes."
After the action in the Coral Sea, Flatley outlined his experience of combat with the Japanese fighter into 8 digestible points he termed hints to Navy VF pilots. Again, in his 1940s vernacular, he gave the following advice. Gain plenty of altitude before contact with enemy VF. You can lose altitude fast, but you can't gain it fast enough when up against enemy VF. Use hit and run attacks, diving in and pulling out and up. If your target maneuvers out of your sight during your approach, pull out and let one of the following airplanes get him. If you attempt to twist and turn, you will end up at his level or below, and you will be unable to gain the advantage. If you get in a tough spot, dive away, maneuver violently, find a cloud. Stay together. The Japs' air discipline is excellent, and if you get separated, you will have at least 3 of them on you at once. You have the better airplane if you handle it properly. In spite of their advantage in maneuverability, you can and you should shoot them down with few losses to yourselves. The reason for this is your greater firepower and more skillful gunnery. Don't get excited and rush in. Take your time and make the first attack effective. Watch out for ruses. The Japs have a method of creating smoke from their exhaust, which doesn't mean a thing. Set them on fire before you take your guns off them. Never hesitate to dive in. The hail of bullets around the cockpit will divert and confuse them, and will definitely cause them to break off what they are doing and take avoiding action. This short lesson in aerial combat would make its way into the hands of a young naval officer, the executive officer of VMF 121, Captain Joseph Foss. Later that year, Lieutenant Commander Jimmy Flatley, while commanding VF-10 aboard Enterprise, had been taught Thatch's beam defense tactic by Lieutenant Butch O'Hara and passed the lessons on to his pilots. Trying it in combat, he saw its effectiveness and dubbed it the Thatch Weave. It would be taught to every American pilot who fought in the Pacific from there on out. Of course, we can't forget the Japanese who, as Flatley himself said, had excellent air discipline, which was the result of hours of formation flying. The Japanese favoured a traditional Vic formation, but with some important adaptations. To avoid subjecting wingmen to multitasking between flying close formation and looking for the enemy, the formation was changed. In the revised combat formation, one wingman would fly 200 meters behind the leader and the second wingman around 300 meters behind. The second man would also fly 200 meters above the leader and the third 300 meters above. Each man can now keep a better lookout for the enemy. When one was found, the leader of the Shotai or element initiated the attack on an enemy aircraft or formation. The leader could also deploy his wingman into line of stern or line abreast as the tactical situation required for sequential passes against the target. The formation worked well for defense too. If the leader was attacked, then he could pull up, trailing the Wildcat, and open it up to attacks from his two wingmen. Generally, the Vic formation worked well for the Japanese, but as the war progressed and due to the lack of radios in many land-based Zeros, the new recruits couldn't maintain the high level of mutual support. Ultimately, we could argue that the Americans broke the Zero's back by employing tactics which removed its effectiveness in combat. Of course, this is not to say that many a Wildcat was not drawn into a climb and then found a Zero pilot on his tail who had just performed a Hinari-Komi maneuver. It would also be wrong to say the Americans had it all their own way. The Japanese were constantly evolving in their approach to combat. A good example of this were the ambushes they mounted over Guadalcanal in late 1942. The under-strength Tainan Kokutai, operating out of Rabaul, were feeling the sting from newly adopted bomb intercept tactics being used against them, the brainchild of Major John L. Smith, commander of VMF 223. With early warning available via a network of Allied coast watches along the slot, the Wildcats of the Cactus Air Force could gain vital altitude above incoming Japanese formations. Once 4,000 or 5,000 feet above the attackers, Smith would mount slashing hit-and-run attacks that the escorting Zeros, often behind the bombers, couldn't intercept. These successful American interceptions continued on and off as the weather held. The Japanese started to change their escort tactics in favour of fighter sweeps using incoming bombers as bait. Several attempts were made to catch the Wildcats at a disadvantage, but the Tainan Kokutai didn't have their chance until October. On the 2nd of October, the Zero pilots scored their most decisive victory over the American Wildcats in a near-perfect ambush. Major Smith scrambled with 13 Wildcats from VMF 223 and VMF 224. Climbing out of the clouds at 25,000 feet, he was shocked to see 17 Zeros diving down on his division. The Japanese fighters shot up Smith's Wildcat, forcing him to crash land a few miles from the airfield. Fellow Ace Major Robert Galler was shot down for the second time, and 3 other US Marine Corps and 1 VF-5 pilot were missing. The Americans quickly repaid the Japanese the next day, with 29 Wildcats jumping a formation of Zeros from 33,000 feet. So right up until the end of 1942, Wildcats and Zeros were still locked in a deadly combat with no clear winner between them. As vital as the tactics that each nation employed to try and save the lives of its pilots were, the aircraft themselves also played a role. By their very nature as carrier fighters, both aircraft were incredibly strong and durable. However, this is as far as the similarities go with the Wildcat and Zero. Although not expressly built to be a flying tank, the Wildcat turned out to be an immensely resilient fighter, one that could take hundreds of 7.7mm rounds and its share of 20mm too. Many a sailor and marine owed his life to just how much punishment the stocky F4F could absorb, including several notable American aces. While the F4F3 variant was not built with any pilot or system protection, the later F4F4 that started arriving at the front in August 1942 was. With more up-to-date information coming in from combat in Europe and the first few months of the war in the Pacific, the need for self-sealing fuel tanks and armour protection was more readily appreciated. The Wildcat was given both improved fuel tank protection and around 150 pounds of armour for the oil tank and behind the pilot's seat. In addition, a 27-pound bullet-resistant windscreen replaced the earlier standard glass version. In his memoir, Saburo Sakai recorded his amazement when, in one combat with a Wildcat, he fired more than 200 rounds of 7.7mm ammunition into his opponent. The Zero ace noted that the Wildcat continued flying as if nothing had happened. But this protection didn't come without compromise. With an added 900 pounds to the Wildcat's gross weight, there had been no increase in the engine power to compensate. This meant that the maximum speed of the Wildcat dropped from 330 miles per hour to 318 miles per hour in the F4F4, and the rate of climb from 2,300 feet per minute to 2,190 feet per minute. This was seen as another retrograde step in the eyes of many Wildcat pilots. The Zero didn't quite have the same durability as its American adversary, and there I'm being kind. Built to be light and strong, no thought was given to protecting the pilot or fuel tanks. While the Wildcat would be loaded up with heavy armour plating, the Zero was never treated to the same care, at least for the Model 21 and 32s. When you hear stories of Allied victories over the A6M2 Zero, a common theme crops up time and time again: a fireball. While not uncommon for less armoured aircraft, this Japanese fighter seemed notoriously vulnerable to a well-aimed burst of Wildcat fire. As one US Marine Corps officer put it, with some exaggeration,
"A Zero can't take 2 seconds fire from a Grumman, and a Grumman can sometimes take as high as 15 minutes fire from a Zero."
Committed to the notion of a decisive battle to win the day, Japan failed to husband their few but highly trained pilots, which ultimately opened up more weaknesses within the ranks as the war progressed. With a few key exceptions, most aerial warfare in the Second World War relied on exploiting an aircraft's range, for at least one side. The Pacific theatre was particularly reliant on long-range bombers and escorting fighters, and in this the Japanese had the ideal aircraft. As we've seen already, the Koku Honbu, or the Japanese Aviation Bureau, had expressly asked for an aircraft that had a range of at least 1,010 miles. The Japanese Zero was able to fly that, and then some. The Zero's long-range capabilities were exploited almost from the first days of the war. The 3rd and Tainan Kokutais, which were land-based units, engaged American fighters over Clark Field on Luzon Island in the Philippines during the Japanese invasion. They had taken off from their bases in Taiwan and flown more than 500 miles there and back. In August 1942, flying from Rabaul, Zeros would make a 6-hour flight in a bid to gain air superiority over Guadalcanal. Each aircraft carried and retained its drop tank and had fuel for just 15 minutes over the island. The flight was extremely dangerous as no suitable alternative landing sites lay between Rabaul and the disputed island, a distance of over 560 miles. As many of you know, the great Japanese ace Saburo Sakai completed this flight half paralysed and blinded through combat with the enemy. This feat of range was so great that often when the Zero turned up, it was understandably thought to be an aircraft from a nearby carrier, not from a distant land base. Of course, not all variants of the Zero had such long legs. The A6M3 Model 32, which had been fitted with the Sakai 21 engine, not only consumed more fuel, but had its fuel tanks reduced in size to compensate for the added weight of the engine. Only the Model 21 could fly the slot between Rabaul and Guadalcanal. The Wildcat, as a much heavier aircraft by over 2,000 pounds, had a much shorter range. The F4F3, based on my sources, had a range of about 860 miles, while the heavier F4F4 could range roughly 830 miles. This not only limited its hunting range, but also meant that the carriers which relied on the fighter for protection and escort had limited attacking range too. Ultimately, the Wildcat and the Zero were two aircraft that became well matched, but not because they had been designed that way. Each fighter was limited by its requirements to operate on a carrier. This meant that power plant selection was limited, as was overall weight. While the Japanese designers made the Zero as light as possible, Grumman produced a heavy fighter, which in hindsight was a design that did little to meet the threat of the more maneuverable Japanese fighters. As a stopgap fighter, it held the line during the dark months of 1942 and gave the Americans time to bring their Hellcats and Corsairs to bear the following year. What saved the Allies in 1941 and 1942 was suitable tactics and training which used the strengths of the pilot and the plane against the enemy. I would argue that the Japanese were let down by their own doctrine and thriftiness. While Mitsubishi was able to produce an incredible aircraft that did everything the Imperial Japanese Navy wanted it to, they were also hindered by these requirements. The lack of armour and the protection for vital systems in the aircraft, along with a military approach which didn't entertain a war of attrition, led to the decline of the Zero's reputation. While carrier-operated Zeros generally took on the added weight of the radio, which was vital for ocean navigation and communication, land-based aircraft did not. The lack of communication during the battle over Guadalcanal, for example, meant that escorting Zeros from Rabaul were less effective than they could have been if in direct contact with their bombers. This lack of communication between element members was overcome by years of training together. As soon as experienced Japanese pilots were lost and replaced with greener recruits, air discipline suffered and Zeros became vulnerable to attacking Wildcats. Training ultimately won the day. As the US rapidly geared up its flight training program in 1940 and beyond, the Japanese never managed to do the same. Even as the Mitsubishi and its A6M5 and A6M6 variants improved, the men who flew them were less and less skilled. The Wildcat had its fair share of aces among the Navy, Marine Corps and Fleet Air Arm. The same could be said of the Mitsubishi Zero. The top-scoring F4F ace during 1942 was Captain Joseph Foss, who had studied Jimmy Flatley's hints to Navy VF pilots. Foss scored 26 confirmed aerial victories, many of which were Zeros. This was his contribution to the eventual 1,514.5 victories attributed to all US-flown Wildcat variants. This does not include the British efforts in their martlets. Some of the top names in the annals of Japanese fighter aces flew to war in the Zero. Hiroyoshi Nishizawa, who claimed 102 victories, Tetsuzo Iwamoto, who is credited with as many as 242 by some sources, and the indestructible Saburo Sakai, who bagged 64. The total number of aircraft destroyed by the Zero is unclear, but some estimates place it at least 1,550 American aircraft between 1941 and 1945. So with other Allied countries represented, it must be at least 2,000 or even 3,000 victories. So which of these aircraft would you want to find yourself flying in 1942? Let me know in the comments and feel free to fill me in with anything you think I might have missed. And if you've enjoyed these videos and you'd like to help me produce more, then head over to my website calibanrising.com/support, and there's loads of ways that you can get involved. A really easy way to help is just to like the video to help it spread to even more people. And why not watch the video on screen for you right now? I'll see you in the next one.